The National Electrical Code, or NEC, mandates that lighting in a room must be controllable from every entry point. This requirement ensures both safety and convenience for occupants. The underlying principle is to prevent individuals from having to navigate a dark room to find a light switch, thereby reducing the risk of accidents such as trips or falls. The specific requirements are detailed within various sections of the NEC, focusing on accessibility and usability of lighting controls. When considering the implementation of this code requirement, there are several factors to consider, including the size of the room, the number of entrances, and the type of lighting system being used. For instance, a small room with only one entrance might seem to not need this requirement, but the code still applies. The NEC aims to create a standardized level of safety across different types of occupancies. In larger rooms with multiple entrances, three-way or four-way switching arrangements are commonly employed to allow control of the lighting from each entry point. These switching configurations involve the use of specialized switches and wiring methods to achieve the desired functionality. Three-way switches enable control from two locations, while four-way switches, used in conjunction with two three-way switches, allow control from three or more locations. The wiring for these systems typically involves running traveler conductors between the switches to communicate the desired on or off state. The NEC provides detailed guidelines and the proper wiring methods and conductor sizing for these types of circuits. Furthermore, the NEC addresses the accessibility of light switches, specifying mounting heights and locations to ensure usability for individuals with disabilities. These requirements are in accordance with the Americans with Disabilities Act, or ADA, which aims to promote accessibility in buildings and facilities. The NEC also considers the use of automatic lighting controls, such as occupancy sensors and timers, as a means of complying with the requirement for lighting control at each entry point. These devices can automatically turn lights on when someone enters a room and off when the room is vacant, providing both convenience and energy savings. However, the NEC stipulates that these automatic controls must be installed in conjunction with manual switches to allow occupants to override the automatic function if desired. The type of occupancy also influences the specific requirements for lighting control. For example, in dwelling units, the NEC requires that at least one wall switch-controlled lighting outlet be installed in every habitable room and bathroom. This requirement ensures that occupants have convenient access to lighting control regardless of the room's function. In commercial buildings, the NEC may have more stringent requirements for lighting control, particularly in areas such as corridors, stairwells, and storage rooms. These requirements may include the use of occupancy sensors, timers, or other energy-saving measures. The NEC also addresses the use of low-voltage lighting systems, such as those used for landscape lighting or accent lighting. These systems typically operate at 12 volts or 24 volts and require the use of a transformer to step down the voltage from the standard 120 volts or 277 volts supply. The NEC provides guidelines on the proper installation and wiring of these systems, including requirements for grounding, bonding, and overcurrent protection. In addition to the specific requirements for lighting control, the NEC also includes general requirements for electrical safety, such as those related to grounding, bonding, and overcurrent protection. These requirements are intended to protect occupants from electrical shock and fire hazards. Grounding involves connecting the electrical system to the earth to provide a path for fault current to flow, thereby tripping a circuit breaker or fuse and de-energizing the circuit. Bonding involves connecting all metal parts of the electrical system together to create an electrically continuous path, which helps to prevent voltage differences that could cause electrical shock. Overcurrent protection involves the use of circuit breakers or fuses to protect the electrical system from excessive current flow, which could cause overheating and fire. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important for electrical contractors and other professionals to stay up to date on the latest edition of the NEC to ensure that their work complies with the current code requirements. Local jurisdictions may also have their own electrical codes that are based on the NEC but may include additional requirements or modifications. It is important to check with the local authorities to determine the specific electrical code requirements in a given area. The NEC provides detailed tables and examples to assist in the proper application of the code requirements. These resources can be helpful in understanding the intent of the code and in ensuring that electrical installations are performed safely and in accordance with the code. The NEC also includes requirements for the labeling of electrical equipment and wiring. These labels provide important information about the equipment, such as its voltage rating, current rating, and listing information. The labeling requirements help to ensure that electrical equipment is installed and used properly. In summary, the NEC requirement for lighting control at each entry point is an important safety and convenience measure. By providing occupants with convenient access to lighting control, the NEC helps to reduce the risk of accidents and improve the overall usability of buildings and facilities. The electrical contractors and other professionals should be familiar with the specific requirements of the NEC and should ensure that their work complies with the current code requirements. When installing lighting, be sure to select appropriate wiring and boxes to ensure a safe and effective electrical system. Selecting the appropriate wire size is also important. The ampacity of the conductors needs to be sufficient to handle the load of the circuit. Refer to NEC Table 310.15 for guidance on the allowable ampacities of insulated conductors. The type of insulation also matters. Some insulation types are rated for higher temperatures than others, so selecting the right one is important for safety. Electrical boxes should be sized appropriately for the number of conductors and devices they contain. NEC Section 314.16 provides guidelines on box fill calculations to ensure that boxes are not overcrowded. Using the correct size box is important for preventing overheating and ensuring that conductors are not damaged. Furthermore, boxes should be securely mounted to provide a stable support for devices and conductors. Properly grounding the electrical system is crucial for safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and to energize the circuit. NEC Sections 250.4 and 250.6 outline the requirements for grounding electrical systems. All metal enclosures and equipment should be grounded to prevent electrical shock hazards. The grounding electrode conductor should be sized according to NEC Table 250.66 based on the size of the service entrance conductors. Bonding is another important aspect of electrical safety. Bonding involves connecting all metal parts of the electrical system together to create an electrically continuous path. This helps to prevent voltage differences that could cause electrical shock. NEC Section 250.92 provides requirements for bonding service equipment, including metal conduits, enclosures, and grounding electrodes. The bonding jumper should be sized according to NEC Table 250.102, based on the size of the service entrance conductors. Overcurrent protection is essential for protecting the electrical system from damage caused by excessive current flow. Overcurrent devices, such as circuit breakers and fuses, are designed to interrupt the circuit when the current exceeds a predetermined level. NEC Section 240.4 provides general requirements for overcurrent protection. Circuit breakers and fuses should be selected with an appropriate ampacity rating to protect the conductors and equipment they serve. The interrupting rating of the overcurrent device should be sufficient to handle the available fault current at the point of installation. Wiring methods are also addressed in the NEC. There are various wiring methods that are permitted for different applications, including rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. NEC Chapter 3 provides detailed requirements for each of these wiring methods. The wiring method should be selected based on the environmental conditions, the type of occupancy, and the mechanical protection requirements. Conductors should be installed in accordance with NEC Section 300.4 to prevent damage from physical stress, abrasion, or heat. The NEC also provides requirements for the installation of electrical equipment, such as panel boards, switchboards, and transformers. These requirements are intended to ensure that equipment is installed safely and in accordance with the manufacturer's instructions. Panel boards and switchboards should be mounted in a readily accessible location and should be protected from physical damage. Transformers should be installed with adequate ventilation to prevent overheating. The NEC also addresses the use of surge protection devices, or SPDs, to protect electrical equipment from voltage surges caused by lightning or other transient events. Surge protection devices should be installed at the service entrance and at sensitive electronic equipment to provide comprehensive protection. NEC Section 285 provides requirements for the installation of surge protection devices. Additionally, the NEC includes requirements for special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. These requirements are tailored to the specific hazards and risks associated with each type of occupancy. Hazardous locations, such as those containing flammable liquids or gases, require the use of explosion-proof equipment and wiring methods. Healthcare facilities require the use of isolated power systems and ground fault protection to protect patients from electrical shock. Swimming pools require the use of ground fault circuit interrupters, or GFCIs, to protect swimmers from electrical shock hazards. The NEC also addresses the use of renewable energy systems such as solar photovoltaic or PV systems and wind turbines. These systems require special consideration due to their unique characteristics and potential hazards. Solar PV systems require the use of properly rated disconnects, overcurrent protection, and grounding systems. Wind turbines require the use of overspeed protection and lightning protection. NEC Article 690 provides requirements for solar PV systems, and NEC Article 694 provides requirements for small wind electric systems. In conclusion, adhering to the NEC standards for wiring, grounding, overcurrent protection, and equipment installation is essential for ensuring electrical safety and preventing hazards. Selecting the right materials and following the appropriate installation methods are crucial for creating a reliable and safe electrical system. The requirement for lighting control at each entry point is an important safety and convenience measure mandated by the NEC.